What is up, YouTube? Welcome back to another episode on CodeWithAni. And in this episode, we're going to take a look at the next collection in our list, which is Queue. Next connection in our list. No pun intended there. Okay, so Queue is a data structure which is basically what you see in your real world as well, right? What you call as Queue is what is implemented in Java as well as the interface Queue. What you see in real world is like people standing in a line, correct? And they are taken into accordance based on who is standing first. So whoever is in the first will be treated first, and whoever is coming newly will be added to the queue in the last, right? I mean, you'll go and stand in the last of the queue, and then you'll wait for your turn to be processed. Now that's the exact same thing that happens in the world of Java as well, and queue is a data structure that implements this process of what we call as first in, first out. Meaning whoever is put in the queue first will be processed first, and any elements that you want to put into the queue will go into the last of the queue. Okay, and any element you try to remove from the queue will be removed from the first of the queue. Okay, now within queue itself you have multiple implementations, right? Like we had for list. So queue is classified as two types, two variants or two implementations of queue. So one is an interface that extends queue, and it is called as Deque, which I have already talked about previously. The other one is called as PriorityQueue. Okay, now what is PriorityQueue? I'll come to Deque, but before that let's take a look at what is PriorityQueue. Okay, because Deque itself is having two more implementations, right? One is a linked list, which we already saw in previous videos. The other one is called as array Deque. Okay, now we'll take a look at PriorityQueue first. Okay, what is PriorityQueue? So whenever you want to insert elements in the queue, right, as I mentioned, the queue follows the first in first out principle. That is, whoever is inserted first is the one who is removed first. Okay, and whoever is inserted, insertion happens from the back of the queue. That is the last part of the queue. Okay, now in priority queue, so there is a slight variation, meaning every insertion that you do into the queue will have a priority associated with it. For example, let's say you are inserting a list of integers. Okay, let me show you an example, and as we see it practically, I'll show you a queue of integer. Okay, space a priority queue. Sorry. Put the new priority queue. Okay. Now what we can do is a priority queue dot add. Let me add 10. Okay, a priority queue dot add 15. Okay, a priority queue dot add 5. Okay, now what we expect in a normal queue is 10 is to be processed first, 15 is to be processed next, 5 is to be processed next. But let's see what happens now when I say system.out.println a priority queue dot peek. So peek basically is a method in a queue which says that don't remove the element on the top of the queue, just take a look at what is there in the top of the queue. Okay, next step I'm going to do, after I take a look at it, if I want to remove the element, I'm going to call poll, which will basically remove the element from the queue. Okay, in this case 10. The next one is going to be a priority queue dot peek. Again, let's take a look at what's the next element to be handled. Okay, now let's try to print this out and see what it returns, what it prints out basically. All right, so it says 5, 5 and then 10, right? So what should we expect here? We should expect, okay, a priority queue dot peek should have returned as 10, correct? But it returned 5. And when I said poll, it polled out this 5, which was the last one that I added to the queue. And then it said peek and it saw 10 on top instead of, like, it's all completely jumbled up, right? The reason is priority queue will associate a certain priority. In this case, for integers, the default priority is ascending order, which means no matter the way I insert elements into the queue, even if 5 is inserted last, 5 carries the highest priority because it's the lowest integer, because it's ascending order sorting, right? So 5 is the lowest and gets the maximum priority. Next one will be 10 and then comes 15. So internally it is rearranged as 5, 10 and 15. So when I said peek, it showed 5. When I said poll, it removed 5. And then when I said again peek, it showed that 10 is on top, right? So this is the beauty of priority queue, right? It follows the principle of queue, but within the queue it rearranges the elements based on the priority of each element, right? This particular concept is important because this is how it it is an analogy to the round robin schedulers and other OS related processes that happen within the operating systems, right? They follow a similar approach to priority based processing. So when you have multiple processes happening inside an operating system, the one with a higher priority is executed first, even if it came to the operating system at the end, right? So that's the concept of priority queue, and that's how internally, even in operating systems, it's implemented like that, right? Just giving you an analogy, that's how OS also processes whatever applications they're opening, right? Which has a higher priority will be executed first, even if it came to the processing part later, during a later stage, right? So with that out of the way, let me take a look at the Deque, which is the next one here. Deque is implemented already by two different implementations, linked list and array Deque. What is Deque? Deque is, it's not pronounced DQ, it's pronounced as Deque, okay, DECK, okay. And Deque means double-ended queue. The DE stands for double-ended. So double-ended queue meaning, as I mentioned, right, you can insert elements into the queue from the last of the queue, and you can remove from the top, right? But double-ended queue allows you the opportunity to insert elements on both sides of the queue and remove elements from both sides. Okay, so one of the implementations is your linked list, right? You got a new linked list. Now linked list, as I already mentioned, is a special class which implements both the Deque interface as well as the list interface. Okay, the moment I try to initialize it as a list interface, right, it's accepting queue space linked list because Deque extends the queue interface. Therefore this initialization is also fine, because indirectly queue is a superclass for linked list, super interface implementation for linked list. I don't know what is the exact terminology, but yeah. But instead of this, if I want to say specifically at Deque, this is also fine. So Deque is Deque's implementation of linked list, and I can say an array Deque equal to new array Deque. This is also fine. Internally, linked list will have, as I already mentioned, right, nodes which will be linked to one another, and it basically implements the Deque, meaning you can insert into the linked list from either side, or you can remove elements from the linked list from either side. In array Deque, it is slightly different. It's not like a linked list. Obviously array is different, right? So array Deque uses the dynamic array just like array list, and it's an ever expanding or shrinking array to which you keep adding elements. I think it may not shrink, it may shrink if you remove the elements, but yeah, it will keep expanding the array as and when you keep adding the elements into the array internally. But you can add the elements from the beginning, or you can add in the end. A similar implementation for what we see as Deque, right? The definition of Deque is implemented through both linked list as well as the array Deque. Okay, and they carry the similar methods for implementations, right? You can add, you can peek, poll, all the methods are there. Add first, add last, anything that you want to see in Deque is already implemented by the linked list and array Deque. The only difference is the way they store the elements. Linked list will store it in its typical linked list way, which is using that class node example that I already gave you. Remember, there's a class node and you have pointer to the node, right? You have the data in the node, you have node next, okay, and node previous. So the very same thing. So all the nodes are connected automatically by saying node.next is equal to the next node and node.previous equal to the previous node. So all of them are linked as a list, but it follows the Deque principle of insertion and deletion. Basically double-ended insertion, double-ended deletion. Same thing with the array Deque, just that it is, instead of a node, linked node, it's going to be a normal array which will be ever expanding. Okay, I hope this clarifies a lot of things. There is also a concept of priority blocking queue, which will be useful for multi-threaded environments. I'll talk about that in multi-threading and concurrency, so stay tuned for that video, which will be very soon out on my new playlist, which is going to be on concurrency and multi-threading in Java. Alright, so you guys take care. I'll see you in the next video. Hope you liked it. Hit the like button, subscribe to CodeWithAni if you haven't already to see more such awesome content, and bye bye guys.